In this video, we are going to see how to write an assembly language program to multiply two 16-bit numbers. Whenever we start writing any assembly language code, we need to declare this line. That is, first we need to declare an area and we need to give a name for that area and type of that area. First we need to define an area. So let us take, we have a memory. So in that memory we are taking some part and making this as a memory area. So that we'll give a name for that area as multiply. Here we are writing multiplication program. That's why the name is given as multiply. First we will take a 16-bit number to register called as R1. Let us take a number 1, 2, 3, 4. 0x1, 2, 3, 4. So we will send the data 0x1, 2, 3, 4 to R1 by using an instruction called as LDR. LDR R1 comma is equal to 0x1, 2, 3, 4. This will load a constant value, that is 1, 2, 3, 4 to R1 register. Similarly, we will take one more number, that is 0x2345 in R2 register. So this is also hexadecimal number, 16-bit number. Load this constant value to R2 register. We'll write an instruction R2 comma equal to 0x2345. Now we have taken two values in two register. Next we will multiply these two values. That is, we will multiply R1 into R2 and the result will be stored in R3. To do that, we have an instruction, that is MUL R3, R1, R2. This will multiply R1 and R2 and the result will be stored in R3. How this multiplication is performed? We have two values, 1, 2, 3, 4 and 2, 3, 4, 5. So first it will multiply these two values. We'll go step by step, that is 5 into 4, like that. We will get the value 504. So how it is 5 into 4 is 20 is nothing but in hexadecimal 14. So write 4 here and 1 carry on top of 3. Next is 5 into 3. 5 into 3 is 15, that is F. F plus 1 carry what we had got from the previous multiplication, that is F plus 1 we will get 1 0. So we will keep 0 and we will take a carry 1. Now we will multiply 5 into 2, that is 10. It is equivalent to A in hexadecimal number. We have got 1 carry in the previous multiplication, that is plus 1 is equivalent to B. Similarly, 5 into 1 is 5. We got 5. Next we will multiply 4 into 4, that is 4 into 4 is 16. We will get a hexadecimal value as 10. So we will keep 0 and we mark 1 as a carry on top of 3. Similarly, 4 into 3 is 12. 12 plus 1 is 13, that is equivalent to D. Similarly, 4 into 2 is 8, will directly consider as 8. Next 4 into 1 is 1. We got 48D0. Similarly, we will multiply for all the numbers and we get the answer as 2820404. After all the multiplication, we will add these values. We got the LSB 4. Next we have 0 plus 0, we will get 0. Next B plus D plus C, we will get 2, 4. That's why we have 4 here and 2 carry. We will see in the calculator, that is B plus D plus C. We have taken the programming mode calculator. We will write in hexadecimal number. First is, we have B plus D plus C. We got a number 2, 4. We have a 4 here and 2 is carry. Like this we will add all the values and we will get the value 2. And 20404 we can verify here. We will multiply hexadecimal number, that is 1234 into 2345. We can see here we have a value 2820405. That's what we got. We will start writing the program. To write any program, we need my Keel Microvision software. So open this. We will create a new project. We go on to the project. You select new Microvision project. It will open a new with new project with that. In this we will select the same folder what we have selected for the previous program. Here created a folder as ABC. Here we will create this project. We'll give the name as multiply for this project. We'll save this. And we'll ask for to select the target device. Our target device is LPC21408, that is ARM7 microcontroller. We'll select this, then press OK. It will ask to start, then we'll press no. We can observe that we have created a target which is having a source. Now we need to write the program, so select the file, and now we will get the blank window. We'll save this blank file with the name. We'll go to the file, save, and we'll give a name multiply, and extension should be .asm. As we are writing a program in assembly level language, that's why we need to save with .asm as the extension. Then we will save this file. Now once we save this, we need to add this file to our source group. Select add existing file to source group. Here we need to select ARM source, ASM source file. We'll select this multiply and we will add this. Once we add, we will close that window. You can see here in a source group we have added multiply.asm file. We will write the SEP program. We need to write these directories and these instructions after a tab. Other than this, that is label, are written without any tab. Here we have taken two label. So these two are label just to indicate we are starting the program. These two label are not written with any space or tab. Other than that, we have directives as well as instruction that should be written after a tab. Now once we have written the program, we'll save the program by clicking on Save Next. We'll build the program by clicking on this Build Target icon. Now if you see, we have any errors or warning. One can see here we don't have any error or warning. It is showing 0 error and 0 warnings. Once we have built a program, we need to debug this program. As we click on this debug start or stop icon, here we can see that we have a program, and in the left side we can see our register. We can see all the registers are having a value 0. Now these two arrow marks indicate we are learning this instruction, that is LDR R1, 0, X1234 will be 7, and we'll click this step. These step buttons are used to debug step by step of the instruction. If I take once the instruction, that is R1 is filled with a 16-bit binary value, that is 1234. One can see here we have a value in R1 0x00001234, that is a 32-bit. The register R1, we have a 16-bit value 1234. Other 16 which are zeros. Next we will process. Once again step icon, the value 2345 is loaded to a register R2. The next register is multiply this R1 and R2, and the result is stored in R3. So we get the value 028200404. The result we can verify in our calculator, that is we multiplying 1234 and 2345 hexadecimal value. They are getting the answer 2820404. The same value we have got here 2820404 and register R3. This is how we will write the program, and we can multiply two 16-bit numbers. And the result is stored in another register R3. One can change the value. To change the value, we need to exit from the debug session. We click on this stop, the work session icon. We'll write another number 1234 into 1234. That is, we will change the values and we will save the value. To save the program, next we will rebuild the program. We can check any errors and warnings. Then we'll run this program step by step. That is, first 1234 is loaded to R1. Next, in R2 also we will load 1234. We will multiply R1 and R2. That is 1234 into 1234. We will get the answer 14B5A90 in our R3 register. If you are multiplying two 16-bit values, we can get up to 32-bit result. Here we got this result.